So I've been thinking eventually maybe I'll start taking some jobs in my shop for other people, maybe some other businesses, we'll see. Been going through my lathe here, making sure I have all the essential tooling on this newer lathe I've got. I don't want to take a job for somebody and find out I don't have the proper tools to do it. So if you had seen my video where I made some plastic bushings for the deck on my riding lawnmower, you'll see that I kind of cobbled together an old boring bar and an old parting blade just to get the job done. It was less than ideal. I was using a small parting blade and a holder in a holder, and the boring bar was even a bigger problem. Luckily I didn't have to do a very big hole or very deep hole in that, and it was just in plastic because it wasn't a very rigid setup. So in my tool post here is set up to take 3/4 inch tools. So I can take a 3/4 inch boring bar and I can put that directly in this tool post holder, which is fine for anything that any holes that I can need to bore out with a 3/4 inch bar. But if I go bigger, want to go bigger than a 3/4 inch bar in case I need some extra depth, and I want a bigger bar, a bigger, more rigid bar, that's going to be a problem. I don't have a way to hold one of them. You know, you can go about 5 or 6 times the diameter of your bar is how much you can have unsupported in the air. That's kind of a general rule of thumb. So I might be able to get about 5 inches of hangout on this 3/4 inch bar, but if I need to do a hole deeper than that, I'm going to have a problem. So I had an idea if I could get a boring bar holder to fit in this 3/4 inch tool post holder. I looked around and I really didn't find anything that really appealed to me. I think I'd like to be able to hold up to 1.5 inch boring bar in here. That'll do most any of the work I can ever see doing on this lathe. You know, this is only being a 16-inch lathe. So I figure I'll make a boring bar holder out of a block of steel, make it mount in this 3/4 inch tool post holder. So I got a chunk of 4140. It's a little bigger than what I need, but I'll carve this up to fit in this tool post holder. This tool post holder is about 4.5 inches long. So maybe I'm thinking about making the boring bar holder 4.5 inches long, so if I need maximum rigidity I can push it back and get underneath all 4 screws and have maximum rigidity, or else it gives me the option I can go down to 3 screws and maybe stick out a little further out this side if I need a little more extension on it. So this is quite a chunk of 4140 that's going to go in here. This, as you see, this is a 3 by 4 1/4 by 6 inch chunk. I was able to buy that on the online auction site. I think this is a cutoff. Chunk of 4140 like that still costs a fair bit, but it was probably about 2/3 of the cost buying it at a local metal shop. So I'll end up making a 3/4 inch piece to clamp in here, and I'll put a hole, 1.5 inch hole in here to take 1.5 inch boring bar, and then I'll put some screws in to clamp the boring bar inside of here. In order to do smaller boring bars, then I'll make bushings, maybe some bushings with some heads on them, and go in here to reduce down to some more common sizes. You know, go down to 1 inch, 5/8, stuff like that. Maybe even 3/4, so I can use this boring bar holder instead of putting a 3/4 bar in the tool post here. So that's the plan. Let's get to it. Okay, I got this chunk of steel up in the old well saw here. I got the coarsest blade I own in there. Probably not quite coarse enough for what we're doing here, but we'll get by. A little drip oil around there too, and feed a little bit of dark cutting oil manually. So here's the chunk of steel I've got here. So I'm going to end up wanting to be 3 inches by 3 3/4 by about 4 1/2 long. See, I've given a little extra over 4 1/2, so I've got plenty of material to clean these ends up. This direction here, it's about an 1/8 inch over 3. This direction, I'm over 4 inches, so I've got a lot of stock to take off in this direction here, but only an 1/8 inch in this direction. So I'm going to want to first start, we'll clean these ends up flat to get started, and then I'll work these faces in square. You can also see this is the side that was up against the vise in the saw, so that's fairly square. And this is the side that was up against the vise in the saw, so that's fairly square. But as you can see, it is not square at all on the sides. There's quite a angle there, which is fine because we've got material to take off of. But since these surfaces, these 3 surfaces right now are the squarest to each other, those are the ones that I'll start squaring up in the middle here. Okay, so here it is in the vise. I've got my 2 squarest, my square side back here. That's square to the saw cut. The saw cut's on the opposite side. I also checked that this saw cut over here, which you can't see, is square to the bottom of the vise. So that'll put this face square with this face, and also square with that face. Now there's quite an angle on here. You can actually see this is a fairly thick scale I've got. See, it's only touching up on that front edge. Because this is rough, I've also put a piece of copper wire in here on the movable jaw, just to make sure that this face is held tight and square on this jaw. This is my main jaw that I know is square to the machine. Now you notice this new cutter in here. I did a video not too long ago where I did some work on the shaper because I didn't have a face mill. This is a 4-inch face mill that I got in a package lot. This is actually the first time I'm using it. And there is some use on these inserts. Before I rotate them, I'm gonna cut with it just to see how it goes. I do not have any power feeds on the X or the Y of this machine. I do have a power feed on the quill. So I don't know how good of a surface finish I'm going to get manually feeding it, but this is 4-inch cutter. I'll clean this up in one pass, and the carbide should do a pretty good job in this 4140. So, I've got my spindle speed set up to 325 RPM, and see how it works. See, it's hit on this edge first because it's so far out of square. I'm just going to take about a 10,000ths pass to start with just to see how this cutter performs and see how this cleans up. But I expect I'm going to have to cut quite a bit off the surface to get it flat. I've taken 30,000ths off there. You can see just how out of square this is. So inserts seem to be holding up okay. I've only got a 1 horsepower motor on this mill, so I don't want to push this too hard. You hear it's a little rattling in the head of this with this cutter, but I think I'm pushing the limits of my machine here. I guess I could have probably put this in the horizontal and roughed it out, but it's up in here, so I'll rough this out. So I started taking some full width cuts with that big 4-inch cutter. I started tripping the overloads on this mill. So I've got this 2-inch carbide insert end mill here, which is actually given to me, a gift. So we'll try that out, rough it in with this, and see how this does. Should be less load on the mill. Got this running at 660 RPM, which is, I don't know, it's probably, based on the calculations, it's probably 25-30 RPM too fast, but with this belt change mill, you can only get so close. Belt. Got fresh sharp inserts in this mill too, so this gives a decent finish. We'll just go with this one. Could have probably changed those inserts in that other mill too, that might have helped. But I already tell this is using a lot less power on the mill. Plus I'm only taking probably 9 to 10,000, so I'm just skin cutting it. Sound as deep as that was, so clean this side up. Part of the problem, I had such an issue with that big face mill drawing so much power. After I took it out of the machine here, I noticed I did a pretty good job of wiping the inserts out. I think the mill scale on here is pretty rough, and it's taking a toll on these cutters. So I went over this with the flap disc first, knock a lot of the loose stuff off. Even the flap disc had a hard time getting it. So I'm gonna be a little more aggressive on my first pass, try to get up underneath that mill scale and see if it doesn't dull my inserts so quickly. I'm also going to stay with the 2-inch here so it's not drawing so much power. So this face here, the face I just cut is up against the back jaw, and the original face that was against the jaw is now down. So those are my 2 reference edges I got in the corner there. Checked it once again on the saw cut side. I know it's pretty square. I checked that with the square over here to make sure it's square this way. The mill scale just sounds hard. There's 30,000, that's a lot better, it's not singing. Hearing to get underneath that mill scale. Inserts in this cutter I think are a little cheaper too, so I think there's like 3 of them. Inserts I'd rather do this one. I've got this down to dimensions of both directions, 3 inches there, 3 3/4 that direction. Still got to flip it down and do the saw cut ends. Get those down, get that down to 4, square it off and down to 4.5. Do that off camera, but as you've seen on the big face mill I had in here, I had problems with tripping overload on this mill. I thought because I have a 1 horsepower motor that I was just overloading it. Well, after a while of working this 2-inch end mill here, taking 50 thousandths deep passes to bring this down to size, I started tripping the overloads on that as well. Well, then I realized something. When I first bought this mill some years ago, it came wired for 440 volts, and I rewired it for 220 volts. I rewired the motor on it, changed the fuse sizes and the fuse panels, but I never replaced the overload heaters. So it was set, so the overload heaters right now are set somewhere around 1.6 amps. Of course, this motor will draw up to 3.3 amps at full load. So I guess I'm just now pushing this mill to half its capabilities. So got some of the proper overloads on order. In the meantime, I opened up the electrical panel in the back, and I got a desk fan blowing on the overloads, and I'll just have to take it easy until the overloads come in later next week. So I've got this all cut to size, squared up, parallel, 4.5, 3 inches, 3 3/4. So now I want to put a 3/4 inch, let's call it a tang or something on here, just to clamp in the tool post holder. So the plan is the top of this 3/4 inch tang will be on the center of the hole going through here for the boring bar. So that way the center of the boring bar will be on the center of the spindle. So I've gone and laid this out on my granite. Put some bluing on here and marked a couple of lines to give me some rough guides to rough this out to. And we'll put my big carbide end mill in there, and I'll cut these down, these two surfaces down 3/4 of an inch. Now I marked my lines 50 thousandths bigger, so this is, instead of being 3/4 inch from the bottom, this is only 700 thousandths, and then this is going to be 1.1 inch wide. That gives me 50 thousandths to take off each side, and I'll finish the width of this with a small carbide end mill with a radius on it. I've got a carbide end mill with a 45 thousandths radius on the corner, so that way the corner between this tang and the next surface won't have a sharp corner, be a stress riser where it could crack. You know, something this big, I'm sure I'm not going to crack it, but I'll have that 45 thousandths radius in the corner just to help reinforce things. So I'll get this set up in the mill and start milling this out. I have to rotate inserts on my 2-inch cutter here. Started pushing up quite a burr the last couple of passes on the end here, so I'm thinking it's about time to rotate it. Well, I was going to show you that last pass, but I forgot to turn the camera on. The last pass I took on here was 20 thousandths. It's starting to push just a little hint of a burr on there, so I'm really working this cutter and these inserts cutting through this 4140, but I don't know if you can see there, but right on 750 thousandths, 3/4 of an inch. So this is cleaned up fairly nice. So there's 50 thousandths left on this face, and I'm going to come back over here and do the same thing here, cut this down to depth, leaving 50 thousandths on this face. And then I'll bring a smaller cutter in, and I'll show you that. This is that 1/4 inch carbide end mill I keep telling you about with a 45 thousandths nose radius. So I use a piece of 1/1000 feeler gauge to set it off the length of the tool to here, to this face, because this is a finished face. So I'm going to come back here and start nibbling away at this. Got this old Bridgeport cranked up about as fast as it can go, about 2,700 RPM, 2,800, 2,750. Probably not quite enough RPM for this carbide mill, but I'll take it easily, nibble away in maybe 10 thou passes. Do really easy on it and clean up these two faces. Okay, so I laid out the face of this mark the center line of it, the center line of this square here, 3-inch square, so 1.5 inches in each direction. It's probably not real critical that the boring bar is sitting precisely on center, but I'll get as close as possible. So the next thing I did is I indicated the top of this. I know my tool post here. My tool post is sitting about 48 thou low for a 3/4 inch tool. So I put a 48 thou shim underneath here to bring that up on center. That way this post can go in other tool post holders or other lathes. So of course it'll be precisely on centering at the shim to make up the difference in the tool post holder. So might not matter a whole much, but that's what I did. So then I indicated across the top here. That's pretty decent. That's maybe about 1 thou out, slightly less than 1 thou. Again, not real critical. Put an indicator on here, indicated this face. Broke loose my compound slide and pushed and turned it back until it was fairly close to 0 here. It might be a little less than 1/2 thou out. Not real critical, but in the future, if something ever comes up and I need to know that my boring bar is pretty straight, once the boring bar is in there, if I bore this hole with this running straight on the indicator, then in the future I can just run an indicator on here, and then I know that my boring bar mounted in here will be fairly straight. I don't know if it matters, but that's what I did. So I'm going to end up using my using the main lathe chuck here as an oversized drill chuck. So I got a single-ended center drill in here. I got that turned around backwards. I measured off this surface down to the side of the center drill minus the radius of the center drill and set that so the center drill is on center, and it looks like it lines up to my center line marks that I scribed in the front of this fairly well. So I did take the run out of this chuck. This is a set true chuck, so even though it's 3 jaw, I can dial it in. So I know it's running pretty true right now. So I was able to open up the bore in here and drill it up to about 1.25 inches. Final size is 1.5 inches. So I got to do the last 1/4 inch of the boring bar. It's actually the first time I've used this boring head. I picked up this Monarch boring head actually for my to use in my horizontal mill, but I kind of got it rigged up in the chuck here. It's a little long, but it seems to be doing okay without too much chatter in it. So I'm taking 20 thousandths deep passes, well, 20 thousandths on the diameter, 10 thou per side passes, just to get it close, using the graduations on the side of the head here. Of course, once I start getting down to size, I'll take lighter passes and take some spring passes, and I'll make adjustments on this boring head with an indicator on the side of it to be a little more accurate. But feeding about 6 thousandths per revolution. I'm only going a couple hundred RPM. It's not probably the most rigid on this up on my cross slide like this, so I'll just take it easy. doing the final pass here. I swapped out for a sharper boring bar, next size up. And here it's still right on the edge of chatter, but I think the finish is pretty decent inside there. So this will bring this right to 1 inch size we need, and yeah, after that, take this out, chamfer this edge here wide enough to put some 3/16 screws in them, 4/16 3/16 screws that clamp the boring bar, and that'll pretty much finish off this holder, other than the adapter sleeves for the smaller bars. So here is the boring bar holder. It's pretty much finished here. I gotta get some flat bottomed set screws to go in here. So this will allow me to hold a 1.5 inch diameter boring bar in here, so I can do some deep boring on this lathe. It should be plenty rigid enough on here. And it still allows me to use other tool positions on here. So I don't have any 1.5 inch boring bars. The biggest one I got right now is a 1 inch boring bar. Obviously that doesn't fit. So what I'll do is I'm going to make some bushings to go in here with a head on them, so that I can adapt 1 inch and even smaller boring bars, and all on the same rigid holder. So, but this video is already long enough, so that'll be another project for another day. So I'm gonna go clean all my machines up, and I hope you found this interesting, and maybe it give you some ideas, some tooling you can make for your own shops. See you next time.